Alrighty, welcome back to Fun Maths. Today we are starting to look at rates of change, or the very early stuff in calculus. So let's get stuck into it. Today we're looking at recognizing relationships. Yep. So first example here is imagine you've got some vessels that are going to hold some water. And as we know, when we pour water in, depending on the shape of the vessel or the jug or whatever you want to refer to it as, that level of the water is going to change. Yep. So the rate of change is going to vary depending on the shape of the vessel. So in this particular case, they're asking you to draw a graph that shows the relationship between the height of the water, so how fast it's going up, and the volume that's being poured in. So with vessel A here, you'll notice that it's the same width as we're going along. So when we pour the water in, it's going to be going up at a constant rate, a steady rate. And once it heads up to the neck of it, obviously it's not as wide. That's going to go up quite dramatically at the end there. So what we're looking at here with the solution, notice we are sketching it with the volume here on the x-axis and the height of the water here on the y-axis. As we said, a constant increase until it gets to here, and then it's going to still increase, but it's going to be increasing at a faster rate, so it's going up faster. It's got a larger gradient there. Here with this one, as we're pouring it in, obviously it's quite wide at the bottom there, so it's going to take longer for it to fill up at the height of it, because there's more to go across here. So it's going to start off slow. It's going to go up, and as it's going up, as it gets narrower at the top, it's going to increase. So you can see here, it's going up, but slowly, and as the neck is getting narrower, it's increasing at a sharper speed there. The rate is getting greater for the height. And then we've got the neck obviously at the top here, where it's going to go up quite fast. Again, this one here, we've got the vessel. Obviously, it's going to be increasing as we go up, but it's getting wider. So it's going to it's still going in a positive direction, but it's going to slow down a little bit up until this particular point. As you can see, it's increasing and slowing down. Here it's getting narrower again, so the height's going to increase faster. So it's still going up, but it's going up at a faster rate from that point until you get to the neck again, where it's going quite positively fast. Here, obviously, this is an unusual looking vessel. You need to apply really the same sort of skills for each of those. Again, it starts off quite wide. It's going to take its time increasing and get faster until it gets to that sharp point again, where it slows down again, and so forth. Cool. Next particular exercise or example. Oh, it's the particle. Yep. So in this particular case, it says a particle travels in a straight line. Perfect. We've got a graph that shows the distance from the origin. Here's the origin and how far the distance in meters over a period of time. Perfect. We've got the graph here. It's asking us to describe what we see on this particular graph. So at the start, at time equals 0, you can see it's starting 5 meters away from the origin. Yep. So particle is initially 5 meters away from the origin. It's not starting at the origin, it's starting 5 meters away here. From here, it's moving until this particular point. So it's moving at a constant rate until, you can see here, this is at 3 minutes. Now, we can work out the rate as well by working out the gradient of that line. So again, this has a rise of 5, from 5 to 10 is a rise of 5, and a run of 3, from 0 to 3. Rise over run is 5 over 3 meters per minute. So here, for the first 3 minutes, as I said, it's going at a constant speed. You can see it's a straight line there, and it's going at the rate of 5 over 3 meters per minute. Once we get to this particular point, we're 10 meters away from the origin. You can see that the gradient or the slope of this graph is 0. Yep, which means that it's remaining, or the particle is remaining stationary. It's not moving any distance away from the 10 meters. It's just sitting there at that 10 meters. Now, to work out how long it's sitting there at that 10 meters, you can see from here, from the 3, where it's got the straight line and it's not moving, to the 7, that's a time of 4 minutes. So for 4 minutes, it's just sitting at 10 meters away from the origin, not moving, which is what we're describing there. So at the 7-minute mark, this is where the particle is moving back towards the origin. And you can see here it is gradually decreasing its speed so that it comes to the rest here at the origin. And it arrives at the origin at 20 minutes, or time equals 20. Cool. Now, what you need to know about this exercise is the following. It says if a graph shows that the y is increasing as the x increases, then we can say that the rate of change of y with respect to x is positive. That is, the graph slopes upwards. So here you can see this is going in a positive direction. It's going up, and it's going up here. Positive direction, it's increasing. If the graph shows that y is decreasing as x increases, so as we move along through x, and it's going down the y value, then we can say that the rate of change of y with respect to x is negative. You can see it's going down or down this way. Yep. In this particular case, you would say the graph slopes downwards. Yep. It says if y remains the same value as x changes, the corresponding graph is a horizontal line. And we say that the rate of change of y with respect to x is 0. So again, if you had the horizontal line, it hasn't got a positive gradient, it hasn't got a negative gradient. As we say, the rate of change of y with respect to x is 0. All of this is consistent with the gradient or the rate of change of a linear function, which we've spoken about before. Alright, last thing I want to talk about is this example. It says for the graph here shown between -2 and 3, it says use interval notation to describe the set of values of x for which first one's asking where the rate of change of y with respect to x is negative. So we're looking for where the graph has a negative gradient. So from -5 up to here, the turning point, which is at -3, that's going in a positive direction. So that's not the negative part that we're looking for. From here, however, from -3 down to here at 0, it is going down. It's a negative gradient. Actually, I can draw that on there. It's going up to that point. It's going down here, and from 0, it's going up to in a positive direction. Yep. So if they're asking, hey, whereabouts is the rate of change of y with respect to x? Where is it negative? You can see that this is the part where it's got a downwards gradient, and that occurs between -3 and 0. So again, using the interval notation, you would say the rate of change of y with respect to x is negative between -3 and 0. And again, we're using those round brackets there because we're not including the points at -3 and at 0. The last part is saying, hey, what is the rate of change with of y with respect to x when it is positive? Okay, so again, we're looking for where it's positive. It's positive between -5 and -3, and it's positive between 0 and 2. So again, to write this using the interval notation, you would say between -5 and 3. Again, we're using a square bracket here because we're including -5 on this particular end because of the way the graph is described here. It's included to -3. Union, so it's saying between -5 and -3 and between 0 and 2. Notice again, this 0 is not included, but the 2 on the end is for that interval. Alrighty, thank you very much for listening up. I hope you have fun with this exercise. Bye for now.